Hi and welcome to this course on Robot Operating System 2. You want to develop powerful and scalable robotics applications, you want to learn ROS2 from scratch and master the core functionalities, but without the usual steep learning curve, well, you are in the right place. I am Edward, a software engineer and entrepreneur. In the past, I have programmed an entire 6-axis robotic arm with ROS from scratch. Then I have worked extensively with ROS2, and I am now sharing with you the practical knowledge that I got. In fact, I have already taught ROS2 to tens of thousands of students from all over the world. Now, when I first started using ROS, I had trouble finding well-structured courses and tutorials to show me what's important to do at the beginning, where to start, what to focus on, and which path to follow. That's why I created the course that I wish I had when I began, so you can learn much faster than I did. This is a step-by-step course, structured in a way that makes it easy to follow for beginners and directly going to the point through a ton of practice. At the end of the course, you will master the ROS2 basics and you will be able to create a complete robotics application using all the ROS2 core concepts. In this course, you will not only see the how, but also the why, which is even more important. You will learn how to install and set up ROS2 on a Ubuntu operating system, how to create, build, and use ROS2 nodes, topics, services, messages, parameters, launch files, and much more. All those points are key concepts that you need in order to use ROS2 efficiently. And of course, you will discover some of the most important ROS2 tools which will help you save development time. You will also practice a lot, thanks to many activities. I will take the time to write the code with you, explain every single step, and give you some challenges to make you progress on the key concepts. Oh, and all the code will be written in Python and also in C++, so you can learn ROS2 completely with those two languages if you want to. And that's not all. At the end, you will work on a complete ROS2 project using the Turtle Sim simulation, so you can practice with everything you've seen in this course. All you need to get started is to know how to deal with a terminal and have some basic knowledge in programming. During this course, I will also give you some of the best practices I personally learned when developing with ROS2. Because what I want is that at the end of the course, you are able to develop not good, but great and scalable robotics applications. So if you want to learn ROS2 efficiently and in a practical way, enroll in this course right now and let's get started. First of all, before we even go to the why, when, and what, you have to know that ROS2 is the successor of ROS1. It's basically the next version, but with the same goals and the same core concepts, just better and with more functionalities. So when I talk about ROS2, I also talk about ROS in general and vice versa. Alright, so why ROS2? Let's start with those three robots. What is the common point between them? Well, all the robots you see here are, or can be, powered by ROS2. ROS means Robot Operating System. It is something between a middleware and a framework built specially for robotics applications. ROS' goal is to provide a standard for robotics applications that developers can use and reuse for any robot. Once you know how to use ROS2 efficiently, you will be able to set up a new software for a new robot in no time. You first need to master the basics and core functionalities, which you will see in this course. And then for every new robot you program, you will gain more skills that can apply to other robots. The more you know about ROS2, the easier it will be for you to program and understand the code of any robot. But is that it? No, another part of the philosophy behind ROS is don't reinvent the wheel. Reinventing the wheel is a very common problem in robotics. People always start building new software that is already existing, and thus they don't have the time to work on really valuable stuff. What if instead you could build on a strong software base to directly program high-level functionalities and work on use cases instead of low-level technical stuff that already exists anyway? So this is the why behind ROS. Now, when to use ROS? Maybe you've already started to program robots with an Arduino board or with a custom code on a computer. And what you will quickly experience is that the more sensors, actuators, and controllers you add on your application, the more complex it becomes until you reach a point where everything is mixed up and you can't add any code for a new sensor without a huge headache. ROS2 is here to help you develop powerful and scalable robotics applications. You can use it whenever you want to create a robot software which needs a lot of communication between its subprograms, or if it has some functionalities that go beyond a very simple use case. So for a robot that will just open a door with a servo motor when it detects movement, maybe you don't need ROS2. But for a mobile robot which you want to control with a GPS and a camera, in this case ROS2 might really help you. Alright, you have just seen the why behind ROS2 and when to use it. Now, what is ROS2? Well, it would be hard to describe exactly what ROS2 is in about 2 minutes, even an hour, but here are the 2 main points that will give you an idea of the big picture. First of all, ROS2 provides you with a way of separating your code into reusable blocks along with a set of communication tools to easily communicate between all your subprograms. So let's say you are programming a mobile robot. You can create a subprogram called node for your camera, another node for the navigation algorithm, another one for the hardware driver, another one for the joystick, and so on. And each of those independent blocks will be able to communicate between each other thanks to the ROS2 communications. The second main point is that ROS2 provides you with many tools and plug-and-play libraries that will save you a huge amount of time. And most importantly, that will prevent you from reinventing the wheel. If we come back to the mobile robot, imagine how difficult it can be to compute a trajectory which will make the robot move smoothly, avoid any obstacles on the way, and also work with other robots at the same time. Impossible, you might think, unless you spend 2 years studying mathematics, path planning algorithms, etc. But what if I tell you this? You don't need 2 years. You need maybe 2 days to install a library and figure out how to use it. So with ROS, you have great communication tools and great libraries. But that's not all. ROS is said to be language agnostic. It means that you can program some parts of your application in a language, for example Python, and another part in another language, for example C++, simply because the communication tools don't rely on any specific language. So in this course, we will focus on the ROS2 basics, the core functionalities, and the tools that will allow you to easily start any robot application powered by ROS2 using Python and C++. ROS2 is also open source with an active and growing community. So you can directly see what's going on, you can easily get help, you can share your project, and even contribute if you want to. Alright, so with this quick introduction, you should have a better idea about what ROS2 is and why it is useful. Don't panic though if you haven't understood everything right now. The big picture behind ROS2 is pretty hard to get at the beginning, but after some practice, you will start to get it, and I can guarantee you that you will quickly think that ROS2 is going to be a great asset for all your future robotics projects. Now that you know what a node is, let's create a Python node in our Python package. So we will first write a very minimal code here. We will install and run the node, and then in the next lesson we will use object-oriented programming to improve the node, and from that we will have a code template that we can use for any future node that you create. So let's get started. First, let's go back to our workspace in the source folder here, and then in the package, so my Python package. Okay. What do we have here? Well, we have several files and folders, and if you remember, we have a folder that has the same name as the package. So we go inside that one. So now you see we are in my PyPKG, inside my PyPKG, inside the source folder of the ROS2 workspace. And we have here the init.py. So we will create a new file right here. Let's do touch, and let's name my first node.py. Great, so now we have the file that we can edit. And I'm going to use VS Code. So to open VS Code, you see I have closed it previously. I'm going to go back to the source folder of my workspace. Okay. And then I'm going to do code dot. So I'm going to open VS Code from that folder only. Great, and we can find here the file is going to be here. So let's start to write the code. First, we will add the interpreter line for Python. So like that, user bin and then Python Great, make sure you don't make any typo here. Okay, so this line is going to say that we use Python 3 just in case, for example, you make an executable and you run it like that, it's gonna use Python 3 to interpret and execute the code. And then the first thing we will do is to import the RCLPy library. Okay, so that's basically RCLPy is the ROS2 library for Python. You will need that in all your Python nodes. And as you can see here, I have the auto completion. I can press tab for the auto completion. If you don't have this in VS Code, it's because you haven't correctly set up the extension. So you go back to the extensions here, ROS extension, and you make sure it's correctly installed. So the ROS extension from Microsoft. You might need to restart VS Code, okay? Make sure it's installed, and then you should have the auto completion. Great, so we import RCLPy, and then we also import from RCLPy.node import node. So we import the node class, so N uppercase here. We import the node class from RCLPy.node. Okay, that's all the imports that we need for now. Let's create a main function. So I create a def main. Let's put some optional arguments that we can pass to the main function. And let's name this args. Okay. And what do we do inside this main function? So what do we do inside the ROS2 program? The first thing that you will do, the first line is going to be RCLPy dot init. And you can pass arguments. So args is equal to args. So it has a args argument, okay, and you can give the arguments that you get from the main. So that's the first thing you will do in any ROS2 programs. You need to initialize ROS2. So it's going to initialize ROS2 communications and all the stuff that you need then to create and use nodes. Then we're going to do some stuff. And the last line that you will write is RCLPy dot shutdown. Okay, and you see here again, I use the auto completion. So use the auto completion as much as possible. I really recommend you to use something. So if you don't use VS Code, use something else that has auto completion for ROS2. That's going to be super useful. Great. So RCLPy init, and then at the end, RCLPy dot shutdown. Now that we have this, we can create a node. So let's do node is equal to node. So we use the node class here. Okay. And we need to give it a name. So for example, let's name it Py test. That's going to be our first node. Now you can note one thing is that we actually create a node inside the Python file. Okay. So the Python file itself is not really the node. The node is inside the file. All right. And that's the minimum code for a node. So you just create a node, you initialize ROS2 communication, you create a node and you shut down. Now that's not going to do anything if we test it. So let's add a log here. Let's do node dot. So you see that inside the node, thanks to all the functionalities from the node class from RCLPy, we can do node dot get logger. So we get the logger functionality, and then dot info, for example, with, let's say, hello world. That's going to be our hello world program. And now we have a node that will, well, be initialized and then print something on the terminal. So that's it. I'm just going to add here if name, so double underscore name is equal to, and then double underscore main double underscore. And let's call the main function. Okay, that's just useful if you want to run the program directly from the terminal, then that's going to call the main function automatically for you. Okay, and that's what we're going to do right now. So I add this bit of code. Now it's very important that you save the files. Okay, I see lots of errors of people starting with ROS2 and they forget to save the file. As you can see here, we have a dot, a big dot. If I save with Control S now, it's a cross. Okay, so that's an easy way to see if you have saved the files or not on VS Code. So make sure you save that file. Then let's go back to the terminal and let's go back to where the file was. My Python package. Okay. And well, you can run it with the Python 3 command directly or make it executable, for example, with chmod plus x, my first node. You see now it is executable and I can run my first node directly. So let's see what we have. I press enter and you see we have hello world. So it correctly worked. You see we have an info that corresponds to the info log level here. Then we have a timestamp. And then we have the name of the node. So PyTest. Why PyTest? Because that's what we have defined here. Okay. When we create the node, we give it a name. All right. So that's what you see. But what you see also is if I run it again, we print the log and then we exit from the program. And that's quite normal because here we just initialize ROS2 communication. We create a node, we print something, and then we shut down everything. Now, a quite common thing to do with a node is to actually keep it alive so it can process more stuff, okay? And you just want to keep it alive and stop it when you want. How to do this? Well, after we create the node, before we shut down, of course, we are going to do rclpy.spin, and as a parameter, we are going to provide the node that we have just created. Okay, so we create the node and then we pass it to the spin functionality. And the spin, so spin is a very important mechanism in ROS. And we're going to come back to this a lot during this course. But for now, you just have to know that the spin is going to keep the node alive until you press Ctrl+C. So let's save that and let's start again. And you can see that now we have hello world, but the node is still hanging there. Okay, if I press enter, the node is still hanging there. If I press Ctrl+C now, we exit from the node. So everything is going to be shut down, the node is going to be shut down, and we exit from the program. All right, so I'm going to keep this like this here, and I'm going to explain more about it a bit later. Now, what we have done so far is we have a file, that's a valid file. We have run the file from where we created it directly. But now what we want to do actually when we create a new file like this is we want to install it. We want to install it and create an executable that we can start then with the ROS2 command line. And that's going to be super useful. For example, later we can also start it from a launch file, etc. So even if you can run the Python program like this directly from the source folder here of the workspace, we're going to install the node. And how to install the node? Well, you will just go inside your Python package to the setup.py. Inside this file here, well, you see lots of stuff, but at the end you see entry points with console scripts. And that's an array, that's a list here. So you go inside this, you open double quotes, and we are going to give the instructions to create a new executable. Okay, so I'm going to create it, we're going to run it, and then I'm going to come back and explain a bit more about it. So let's create an executable which name is PyNode. So that is something that I choose. Then I will put a space, equal, space, and then I need to provide basically the path, so the relative path to the file here. So we need to go to my PyPKG. So usually that's going to be the package name. So package name, and then dot, the file name here, it's my first node.py, my first node, but I don't provide the py extension. Okay, so just my first node. Okay, package dot file without the extension, and then we have a colon, and we need to provide the name of the function that we want to call. So when we start this, we are going to call a function from that program. What function we want to call? Well, that's going to be the main function. So we write main just like that, no parentheses, nothing. Okay, so you choose a name for the executable, and then package.filename, colon, function to call. And that's it. If you want to add more executables, you will need to add a comma, go to a new line, and then do the same thing again. Okay, but for now we only have one. So let's save this file, very important. You save all the files. Let's go back to the terminal, and let's go to the ROS2 workspace. Once again, very important, you don't build just anywhere, you only build in the ROS2 workspace folder. That's super, super important. So we are here, I can do, so let's do clear here, and I can do colcon build. Now, because I have two packages and I only want to build the Python one, I'm going to use packages select. So it's not really important, you could build the two packages, but here let's do things in a clean way. So packages select, and then my py pkg. Okay, so we built the Python package. And now what's going to happen is that you just gave an instruction to create an executable. So inside the install folder here, well, you can try to browse inside and maybe find the executable. It doesn't really matter, but basically you know that this executable here, PyNode, is going to be created inside the install folder. And it doesn't really matter where, because we don't need to go inside this. We can use the ROS2 command line tool directly to run the executable. Okay. So for example, let's say I'm in my home directory. Well, you could do that from wherever. And I'm still gonna source the bash rc. So you could do complete path with tilde/dot bash rc. Why is that? Because, well, I have just created something new in my workspace. And because I have created something new, I'm gonna source my workspace. Okay, just to be sure that I have the latest updates. And how to source the workspace? Well, you could source the setup.bash script inside the install folder, but you can also source the bash rc because, well, we already have the line to do this inside the bash rc, okay? So just make sure that you source the workspace if you have created something new, okay, in a terminal. Or you could open a new terminal and then everything is done for you automatically. So, for example, we source that, and then I can start the node with ROS2 run. I will need to first provide the package name. The package name is my py pkg. You see, I can press the auto completion. It should be found. If it's not found here, then you have a problem already, and you need to go back and make sure that you've done everything. And then, well, so I do ROS2 run package name, and then I need to provide the executable name. What is the executable name? Well, once again, the executable name is what we have created here in the setup.py. So it's called here PyNode. So PyNode. And I don't even need to type everything. I can press tab here. Okay, it's gonna be found. I press enter, and you can see it is correctly working. So now I have created a node, I have installed it, and I can run it from anywhere using the ROS2 run command line tool. And now I can do Ctrl+C to stop. So we have a keyboard interrupt, but you don't need to really worry about that, okay? And I'm just gonna come back to one very important thing that you need to make sure to understand is that, so we have the executable name here. The executable name is what's created after you install the node here. So that's PyNode here. But then we also have PyTest. PyTest is the node name, and the node name is what you have defined here inside the code. Okay, so that's two different things. The executable name here and the node name are different things. And then also we have my first node.py. That's the file name. Okay, so we have three different things here. We have the node name that we create inside the file. We have the file name, and then we have the executable name that we create so that we can use with ROS2 run. Okay, three different things. And here I used different names for all three just to show you that there are different things, but sometimes you will see the same. For example, if you create a temperature sensor file, you might name it temperature sensor.py, and then the node name might be temperature sensor, and the executable name also might be temperature sensor. But you need to be aware that those are three different things, okay? And I'm gonna come back to this also later. But for now, well, great, you've made a lot of progress already, because you can create a file here, you can create a file to write a node, you can write a basic version of a node, you can install that node and run that node from the terminal.